I'm gonna just do something
We got just a few minutes, so if you are working on something, you might want to pack it up. You're welcome to stand up and get your stuff together, but I ask that you don't stand by the door, please. So the bell will go off here in a minute, but don't line up at the door. Have a good day. I'll see you tomorrow.
Oh, yeah, you're right.
What does A mean when it's on the number?
A means, let me see, well, who's the teacher name? Michael Thomas. A is going to be way down here by the cafeteria, I think. So, good morning, guys. You need one of each of the handouts up there, and then your seat number will be on the board. Morning. You need the handouts, and then your seat will be on the front.
Do we just look right?
There's the handouts, and your seat number.
Sounds good back.
Grab one of each of those, and your seat will be on the handout.
Okay, I did not put the rest of it. No.
You're 26. Right in here, corner. I just realized how much. Math, 20. I don't think we did. No, but this is great. You can help us. Oh, no. Except I guess we have a second. This is or this is. Yeah, no, this not bad. Why do we have like a whole basis? No, I have that second period. That was Did y'all want to add it? Well, it was a good idea. You don't have to. Okay, guess who's all I did know. How did you get here? Wait, is it full? I'm stressing. It's like legally?
There's no parallel.
I don't parallel. I pulled in like the back. Oh man, yeah, how are you? So we have to see those. I got it. Oh really? Yeah. Oh thanks. Wait, it's whole class. So it's 1 to 1 day.
Dude, I swear, when we were here
Maybe.
No. I don't know why. Bro, these are so much language.
You can like if you're planking down the hallway. I know. So you can change it. I mean, what if the cat slots or like? Yeah, I know. Seriously. I'm trying to think of like Exoot or something.
All right, there. Alright, good morning. I tried to tell each of you if you came in, but I may have missed a few. I've got some handouts for you. You need one of these, so you can grab them and anytime you have some handouts, I'll put them there for you. And to give me a second to get attendance all put in, one of these is the syllabus, so if you would just scan through it real fast. I think it's pretty straightforward, but if there's something you'd like to ask about it, I want to give you that opportunity. So, of these papers, I do ask that you have a binder for this class. So, those of you that had me for pre-calculus last year, it's the same thing. Sir, you need the handouts on the front desk, and then you need to find your seat number over there. That's how I'm taking attendance, so don't just sit anywhere. So even though I do ask that you do a binder, it is very straightforward. I just ask that you number the assignments and keep them in order. So you'll notice that this syllabus has a number 1 in the top right, so it should just be the first thing in the syllabus. Then there's another handout you picked up that has a number 2 in the top right. We'll look at it second. And when you have a binder for this class, you're just going to put it behind number 1. Number 3 will go behind number 2, number 4 goes behind number 3, and that's pretty much it. I'm going to try to number most of the assignments for you this year before I copy them, so I think all but maybe one of today's has the number on there. So sometimes you do need to add the numbers. So scan through the syllabus real fast for me, and let me try to figure out attendance. I guess you guys know this now, but we have last lunch. So the lunches per phases rotate each year. So last year I had first lunch, and this year I have last lunch. So don't assume that you know what lunch you had based on last year's stuff. Okay, Riley. Son. Riley Holt. Okay, so to me, some of the highlights about the syllabus would be your grade breakdown. So it should be consistent with your last few years of math, because we have to keep them all the same. We have a major category and a minor category. Major is 60%, minor is 40%. Major will be all your big tests and bigger quizzes. Minor will be most everything else, like homework, assignments, classwork, small quizzes, mini quizzes, stuff like that. So that's pretty straightforward, I think. Late work is important. I do take late work for half credit, but it has to be 100% complete, and it has to be turned in by the unit test. So if you do it after the unit test, that's great that you did it, but not for points. I feel like that's pretty important to hear. There's the honor code in there, but you should hear that in all of your AP classes, but I have it typed up for you. General idea. So I don't know. I don't know if there's anything else that stands out to you, but is there anything you'd like to ask about the syllabus? You don't need to get it signed or anything. Yeah.
Are there any like retakes for quizzes or?
Not usually. There's like one or two specific ones depending on like what they are and why I would do that. But no, in general, no bonus credit, no retakes. So if that's something you've leaned on a lot last year, if you took pre-cal last year, that's not something we offer in pre-cal, so you should be pretty used to that. But that's a good question. Okay, anything else about syllabus? Okay, then number 2 is this one. I did not number this one. That means you need to number it. So the one that has, that looks like this, it tells you what codes and what classes you need, or websites you need to sign up for. So this is supposed to be number 2. I did not put a number 2 on there before I ran off the copies. So all that means is you need to put a number 2 in the top right, like your number in the book. And when you have the binder, put it behind number 1. So if you have your charged Chromebook, I cannot allow you to use your phones, even if it's for school purposes. So if you have your charged Chromebook, you can take a few minutes to do these things. There's really 3 of them. And I'm going to talk about them briefly while you're doing that and how I use them. So starting with the last one. Now, if you don't have your Chromebook with you today, you know, it's all right here. It's in your binder. You can do it for homework. So you'll just have to do a little bit more outside of class if you forgot your Chromebook. Of course, you know, with no cell phones this year, it will be more important that you bring a charged Chromebook every day. Supposed to do that last year, but it will be extra important this year. Hi, Riley?
Yes, sir.
Okay, you need one of each of those handouts, and then your seat number 1, right back here. Okay, so I'm going to talk about these while you sign up for them. Again, you can sign up for them later if you don't have a Chromebook, but I'd prefer you to just get it done while I'm talking about them. The last one is AP Classroom, and to be honest with you, I don't use AP Classroom very much at all. The questions in AP Classroom are very difficult, and so for the first few months of school, they're usually too difficult for you. Before the AP exam, they're much closer to what you'll be ready for, but by then we're about ready for the AP exam. So I will use AP Classroom for a mock exam around March. Short of that, I pretty much don't use AP Classroom. I just don't think it's the best use of your time. It's still important that you sign up for it today though, because this is how the school knows to order you an AP test. If you never sign up for AP Classroom, the school does not order you an AP test, and you'll show up that day and they'll have to turn you away. So now, it's perfectly fine if you want to take this class without doing the AP test, but that's very, very uncommon. So you should talk to me about that if that's the case. The middle one is your standard Google Classroom. I don't post our assignments on Google Classroom, but I do allow you to turn stuff in on Google Classroom and as an option if you'd rather do it that way instead of hard copies, giving me your hard copy. But also for announcements. So like I have an announcement about a volunteer tutoring activity for those of you who want to get some tutoring hours that I will share later today. Just a good way for me to push information to them. Of course, on those two, make sure that you're using the right class period. You need fourth period. Fourth period on both. If you pick the wrong one, I'll have to just kick you out and you'll still have to redo it again later. So. And then the first one is our class website. This is where I'll put all of our useful class stuff. So again, those of you that had me last year for pre-calculus, you are familiar with this system. But of course it's not the same as your pre-cal page last year, but basically works the same. So while you're signing up for that, I'm going to just point out a couple quick things about it so that you at least know what's available there. So first thing is I do record our classes, and that is mostly for when you're absent, school business, out sick, whatever, a way for you to hear the same thing like I'm recording right now. So you could go home tonight and listen to these directions again. If you misheard, couldn't remember, wanted to hear the explanations again, you know, whatever, that's going to be there for you. And that's organized here on this calendar. So you can see for August 20th, second period, I already posted their class recording. So anybody that was absent in that class, that's what I will ask them to do. I can't summarize 90 minutes worth of stuff in 30 seconds like y'all like me to. So that helps you when you miss class or if you feel like you need a little extra work. I put the agenda in the top right. This is the same thing I had on the screen when you came in. So if you forgot what your homework was, you forgot what I was going to ask you to turn in, you forgot what number an assignment was supposed to be, you forgot when your tests are coming up, whatever, you can glance at that and get caught up real quickly. This stuff you probably don't care about right now. Shows like how the AP exam, information about the AP exam and like how it's weighted. That'll be more important later. Some other stuff that'll be important later. But if you scroll all the way to the bottom, I organized this class website the same way I asked you to organize your binder. So number one's the syllabus. You picked up a syllabus this morning. I don't know why you'd want an extra copy, but if you did, all you'd have to do is click download a new copy, and it should download it automatically. And then if you're at home or in the library or whatever, you can read it or print it. It's ready to go. Same thing with number two that you're using right now. So again, I don't know why you would need a second copy, but if you did, it's there. And then more importantly, things like 3 and 4. This is where we're actually going to get into some of the calculus and the math. So maybe you want a new copy, you wrote in pen and it became a mess. Maybe you want some extra practice. Maybe you want to check your answers. Maybe there's videos of me going over particular questions. Anything that I think helps you guys, especially stuff I've done over the years, I put it there. So it's all organized the same as your binder. So you can see number 3, we're going to talk about this today, and then I even have some like suggested practice. So if you decide that you need to practice those a little bit more, I try to make that as convenient for you as possible. So I try to make it easy to use, but you will need it quite a bit for this class. That's why I ask you to bookmark it. Okay, so this number 2, websites to sign up for. Anything that jumps out at you that you would like to clear up about this? Okay, we're all good still? Does anybody need more time to sign up for these? Okay, then I guess I should give you a quick overview of why we start off with limits. Calculus really only has 3 big topics. There's limits that we only spend about 2 to 3 weeks on. That will be a review for most of you that did pre-cal last year. If you skipped pre-cal or did not do pre-cal last year, you will have to put in more effort the first 2 or 3 weeks because other people have already seen it. But we have to do limits. That's the first topic in calculus. Then there's derivatives would be the second, and integration is the third. There's 3 things in calculus, those 3 things. We have to do limits first because a derivative and an integral are defined by limits. So if you don't know what a limit is, you don't understand the definition of a derivative or the definition of an integral. Integrals are actually just the opposite of derivatives. We'll get to those around December, and we'll start doing derivatives in about 3 weeks. But we actually do about 6 things in this class. So one thing is limit questions, like we're about to look at in a minute. The second thing would be taking derivatives. There's a handful of derivative types they expect you to do by hand. The third thing is applications of derivatives. So there's lots of real-world stuff that derivatives do for us. So we need to do those. The fourth is taking integrals by hand. The fifth is the applications of integrals, so the stuff that it can do for you that other math classes couldn't. And then 6 would be AP review. 99% of what we do in this class will fall into one of those 6 things. Limits, taking derivatives, using derivatives, taking integrals, using integrals, or reviewing for your AP test. And compared to some AP classes, AP Calculus has a lot to it. In fact, this doesn't matter until you start signing up for classes next year. But this shows you the 8 units that we do right here for AB. And just to give you a comparison, students that are in BC just have 2 more units to do. So there's quite a bit packed in to these 8 units. So it takes us the full year to try to get all that in before your AP exam. So that's big picture. So we've got to start off with some limits. And again, I'm going to approach this like it's your first time hearing it, but it should be review if you did pre-cal last year. So if it's not, again, you might just have to spend an extra 30 minutes for homework making sure that you were caught up and understand what's going on here. So this first handout, this is number 3. This one I have numbered for you. So again, you're going to put it behind 2 and in front of 4 when you have a binder. Very easy. Very important for calculus. I know those of you that had me for pre-cal, you probably did a good job with yours last year as well. It's more important for calculus though, because come March, April, May, and your AP test rolls around, there's going to be some of this stuff that you don't remember because it's been 6 months since you've thought about it. Some stuff we use a lot, some stuff we need to be able to do, but it doesn't carry over. So it's very important that your binder is in order because it will be one of your best resources as we move forward. Okay, so start off here. What is a limit? So a limit is going to be the value, specifically the y value. Your answer should be y values. A function approaches from both the left and right side of a given x value. Keyword here is approaches. And you'll see what I mean by that in just a second. So this handout has some examples. I'm going to use these as a way to do a quick little reteach, show you what you need to know, You need to copy the same things down that I do. Most of my assignments are participation grades, so anything I'm putting down up here, you should put on your paper. Of course, you should add to it if you'd like to, but make sure that you have it complete. And near the back of it, you're going to be practicing some of this on your own. Okay, so this first little row of questions, this is not new, but this is a great way to help you identify the difference between what you're used to. F of -3, this is just talking about a point. You've been doing this since Algebra 1 or pre-algebra. It's asking you, what's the y value when x is -3? What's the y value when x is -3? If it doesn't have one, you can say does not exist. D&E, does not exist, is a very common answer in calculus. You don't have to write out does not exist in words. You can just put D&E. F of -3, y value when x is -3. F of -3, y value when x is -3. F of -3, y value when x is -3. That's not calculus. That's the part that you guys should already know. But and these are not my notes. I didn't make these up. I just stole them. And a good reason I stole them is because I like that they're emphasizing the difference between a point and a limit, because that is probably the most mixed up thing come our first quiz in a couple weeks. A limit is about what is it approaching. It doesn't care where it's at. If it cares where it's at, we're going to ask you about points. If we're asking you limits, we're asking you what is it approaching. So it has to approach the same from the left and right side. So let me zoom into this first one. So this is saying if you go to f of x, which I'll assume is this, what value is it approaching, because it says limit, as x gets closer to -3? So you got to go from the left side of -3 to see that the closer you get to -3, the closer it gets to a y value of 4. And you got to come from the right side. As x approaches -3 from the right side, it approaches a y value of 4. If it approaches 4 from the left and 4 from the right, then 4 is your answer. But it's a coincidence that these two are the same. You can see the second one, the graph looks the same. I'm going to do the exact same thing and get the exact same answer. But notice that since this point's gone, it's going to, I don't know. If you don't differentiate these, then you can get that mixed up. So limit as x approaches -3. It approaches 4 from the left. It approaches 4 from the right. If it approaches the same number on the left and the right, that is your answer to your limit question. It doesn't matter that the point does not exist. Limits are not asking you about what happens at that value. They're asking you what does it approach before it and after it. In fact, there's only one like math video that I show you guys, and it's right before the AP exam. But he actually goes even further, and he just says, like, if you want to know the limit as x approaches -3, he just completely blocks this off. Like, if you're doing a limit question, you don't need to know what's happening there because it's irrelevant. It's important if you're talking about a point. It doesn't matter if you're talking about a limit. Okay, so the third one, it approaches 4 from the left, 4 from the right. I could care less where the point is. It approaches 4 from the left and from the right. That's what a limit is asking you. Now, for this next one, I want you to add a couple things to this one here. And then we'll go in more detail at the bottom of this page. So sometimes the question is going to look like this. And sometimes it's going to look like that. It's the same as what they have written up here, except there could be like a minus or a plus sign. Looks like a little exponent. Not really an exponent, but that's what it looks like. This just means from the left, and this just means just from the right. So if you were asked this question, what is the limit as x approaches 3 from the left, you only care about what it approaches from the left, 4. If it has a little plus here, you only care about what it's approaching from the right. So you go to the right of -3, and then you inch closer to -3. It approaches a y value of 1. And those are totally legitimate questions. But if the limit from the left is not the same as the limit from the right, then the limit that doesn't designate left or right, those have to be the same. If they're not the same, you would say it does not exist. So, of course, that's about as long-winded as it can be, but same idea here. If I really just care about this, I think about what's it approaching on the left, what's it approaching on the right. If those are not the same, then it does not exist. Any more time or thought you're putting into it, you might be on the wrong track. Okay, so to go a little bit deeper with the left and right here, this is where it's actually typed up. What is a one-sided limit? One-sided limit is going to be when the value, so again, the y value should be your answer. A function approaches a given x value from either the left, if it's a minus sign, or the right, if it's a plus sign. Same thing I just said. They're just formally having you fill in the blank for the definition. Okay, and then they have one example typed up to make sure that you understand that. So, as x approaches 3 from the left, that would be that. You can see the closer you get to x equals 3, the closer you get to a y value of 2. That's from the right. And then from the left, the closer you get to an x value of 3, the closer your y value gets to -1. From the left, just from the right. And if it doesn't have a left or a right, it has to be both. All right, so next page. Example 3. So using this new graph here, I would like you to try these 10 questions. There's no pressure, just do the best that you can with what we tried on the front page. See how many you can get right, and we'll go over them so you can correct them. But you need to see and make sure that you understand. It's really notation, understanding what it's asking for in each of those. So I'll give you a few minutes to try them. I will share my answers, and we can discuss any of them that you would like to, and then we'll move on. And if you aren't sure on one, just make an educated guess. It's not a problem if you need to correct it. Now notice a couple of these aren't even calculus, so a couple of these are just points. So be careful about what it's asking. Also, it makes a big difference if it wants from the right versus from the left versus both. Like one little tiny symbol can completely change your answer. So make sure you're paying attention. I know some of you are done, but just hang tight for a minute. This is the first time I've asked you to practice. Some people need a little more time, especially if this is the first time you've heard it, so just be patient. Okay, finished or not, let's go ahead and go over the correct answers. Of course, if you missed it, you should probably circle that question. You should probably go back and look at it again outside of class. Make sure that you understand why the answer was what it was. But starting with part A, I got 1, -2 does not exist. 1, -2, 5, -3, 0, 1, and finally -2. So which of those do you disagree with, or which of those would you like me to go over and explain how I came up with that? Y'all are good with all that? Johnny, you good with all that? Okay. Okay, so you don't have to flip your page, but the next page, when we get to it, just ask you to practice this a few more times. So if you made a few mistakes, it's fine. You've got some time to improve a little bit. Okay, next up they want us to talk about when a limit does not exist. So we've already talked about, we've already talked about one of these. If you took the limit of some function as x approaches a number from the left, now I don't know what the number is, so I'm just going to use a generic a. The limit as x approaches a from the left, if that's not the same as the limit as it approaches right, that's when we get does not exist. Example 3c, it approached 1 from the left and -2 from the right. They have to approach the same thing for the limit to exist. Okay, the other two will seem kind of unusual at first, but I'll try to help you understand why you need to hear this. Okay, another one is when, if you take the limit as x approaches some generic number of a function, if that value just keeps going up, sometimes we say the limit is equal to infinity. And this is actually super important mathematically. I wish I had mentioned this in my second period class, because this is the first time in your math careers, unless you did this in pre-cal last year, that you can have an equation that actually equals infinity. Nothing until limits allow you to say something equals infinity. You could say it approaches infinity, but with limits it's already about approaching, so it can say equal. Or we can say does not exist. So infinity and negative infinity are not numbers, they're concepts. So the reason why you need to know both of these is this could be a multiple choice question, and either this could be there and you would pick it, or this could be there and you would still pick that. They wouldn't both be there, but these mean the same thing. And then of course, I guess if you understand that, then the next one is just negative infinity. If it's a free response question, you could say negative infinity, or you could say does not exist, but on a multiple choice, you pick the one that it has listed. I think older questions tend to have infinity or negative infinity, and newer questions tend to be does not exist, but the AP exam is not consistent with that. So that's what would mess the limit up. If the limit from the left is not the same as the limit from the right, or if it approaches infinity or negative infinity, we could say it does not exist. Okay, so for one more question type on this assignment, and then I will give you a little bit of time to work through some of this, and I'll go around and see how y'all are doing. But they also ask you to practice a handful of these. So we're going to do this one together, number 4. And when you get to the back of the next page, there's like 3 more of those for you to practice. So again, this is mostly notation. They're wanting you to look at this and realize, hey, this is just a point. It's saying when x is 3, y is negative 1. So you have to have that point there. This is a limit. So this is about what it's approaching. As x gets closer to 3, both left and right, it gets close to 4. So as x gets close to 3, I don't know, maybe I'll add some curvature there. It approaches 4 from the left and 4 from the right as x approaches 3. I left this an open circle. Why does this have to be an open circle? Right. To be a function, it's got to pass the vertical line test, so it can't hit this point and this point. So it's one or the other. Okay. Try to keep this color coordinated so you can see where these parts come from. This is another limit, so this is just talking about what it approaches. It approaches -2 from the right. It approaches 1. So as x gets close to -2 from the right, it should get to a y value of 1. This should be approaching 1 from the right. Okay, it's supposed to be increasing from -2 to 3. What does increasing mean? Right. From left to right, just like you read a book, your graph needs to be going up. So is mine increasing during that time? Okay, so just accidentally doing the first couple clues. This is going up, so that's already done. All right, and then finally, they want the limit from as x approaches -2 from the left to be bigger than the limit as x approaches -2 from the right, which they told me this was 1 up here. So I just need to make this be bigger. So I couldn't do like this, because then the limit from the left is less than the limit from the right. I just need it to be something like this. And then of course, make sure you show that it goes forever left and right. We shouldn't assume it just magically stops. They didn't say anything about that. And then finally, before I move on, sometimes when you do clue 4, you might mess up clue 2. So check these off, make sure they all still there. My point is still in the right spot. It still approaches 4 from the left and the right for clue 2. It approaches 1 from the right for clue 3. It's increasing during that time like clue 4, and the limit from the left is bigger than the limit from the right at x equals -2. So if all the clues are good, your graph is good. Your graph can look slightly different than mine and still be correct, but if all of those clues are correct, then yours would be fine. Once again, notice they're really just focusing on the idea of the limit and notation. Point versus what a limit is versus increasing versus just comparing the values. Okay, so this is where I'm going to step back a little bit, and I would like you to continue on with question 5. This is true, false. So you can just put a T or a F for each of those. Then flip the page over, and then this question is just like example 3 that we did. Different graph, but similar question types. So you can start on those, and then go ahead and just work along at your own pace for a bit. I have my work up here, and so I will share that with some of you, especially those of you that I can see are working a little bit faster. So that way if you're missing something, you can go and correct it. But I'm going to give you a chunk of time here, probably about 15, 20 minutes or so to just work ahead on this. This is the assignment that I will ask you to finish before Thursday, so if you don't get much of this done, that's okay if you're doing the best that you can, but it just means you'll have a little bit more homework. And I may not give you full time to do it. It just depends on how fast you work. And please do these in order. The last page has 4 AP questions. I don't want you to worry about those until you feel like you're done with the others. So I will check back in on the board and go over some of the answers, potentially go over some of the questions, especially if I'm getting some of the same questions. So I have to insist that you guys go back to being quiet like you are now. But while I'm giving you some time to work, it's certainly understandable to check your answers with your neighbor. If you're all getting the same things, you're probably on the right track. If you're getting something different, you're welcome to discuss it. You're welcome to help each other. I'm going to be coming around the room, so if you have a question, you can call me over when I'm near you. But in this class, you certainly need to work together sometimes and help each other out because there's only one of me. So you're welcomed and encouraged to do that. Just, again, when I ask for your attention back on the board, you'll have to pause your working with your neighbor. So, all right, just call me over if you have a question. So from the left, it doesn't exist, and from the right, it approaches 1. 1 is not the same thing as does not exist. So that does not exist. You're correct. Are you good with that first set? That's real quick. Oh, wow. Over here. Check those for us. Yeah, those are good. Yeah, it just has to be bigger. That's why I said your graph could be different than mine. So as long as all of those are true, then it's huge. I agree with all that except for this one. Those are all good. What you can see. You need to check even. I mean, you know, it's only 1 of 2 things, so you know the answer, but you need to look at those questions as well.
Yeah, I'll check my mode. This is not.
Yeah.
That's what she had on me years ago.
Well, I think.
Yeah.
Did you give me a 12 screw sink?
Yeah, I got you.
Check this real fast.
You guys just
If something's going wrong, we can make adjustments. That one did. Try that one again. Let's check this one, see if it works. Okay. I'm trying to give some people a chance to check that first little group on the next page. So if something's going off, you don't have to redo a lot of it, but try those two again. Check the circle group. Now just this and those. Okay, is anybody still trying the true-false questions? I'm about to tell you the answers to them. Okay, so the true-false questions, example 5, they were all, what?
True.
They were all true except for the last one, G. And I will tell you that I missed that question. I had to fix it this morning. I didn't read it very carefully. The limit as x approaches 2 does exist, and it says it does not exist, so that's why it's false. I just didn't read the question very carefully. So number 5, they were all true except for G. G was false. So any of those you missed, again, circle them, put the right answer out to the side, try them again. It's not the answer that's important. It's understanding why you missed it before you make that same mistake 10 more times on this paper. And then keep going. Okay, so if I'm thinking about this question, what's the limit of x approaches 2 from the left? Okay, there's nothing, right? So it does not exist. And the right it approaches 1, but it does not exist, it's not the same as 1. So the limit from the left is not the same as the limit from the right. So this is that little line that's not from the left. So here's -1 from the left, the y value is getting close to both. Your answers need to be those y values. This one's just from the right. So as you get closer to x equals 2 from the right, it gets closer to the y value of 1. This one is just asking for a point. This is a point. So when x is 2, that's an open circle. So it doesn't exist. And then keep going. I'll let y'all check some of these. We're going to check maybe the first couple of groups just to make sure you're on the right track. Okay, and I can help with. Know which ones you might be. Any of those you missed, just circle them and then I can help you with. Now, most of the time, I don't just have one answer key that I'm kind of letting one person look at here and there. I usually scan this in and put it on the class website. So again, once you bookmark our class website, normally you can just scroll down to number 3, click solutions, and then you can see all the answers and you can check the work at your pace. I just don't have that for this assignment. I'll bring it to you next. She's looking at it right now. fine. Did you check these already? Okay, make sure they're correct. I'm sorry?
So actually asking for to include
No, we can't. Okay. Yeah, but you're looking at x equals 3. This is 1, you know, and x is 2.
Oh, and access to.
Yeah. Since there's only an open circle at x equals 2, that point. Now, especially if this is your first time doing anything with limits, it is a little tricky at first, I will admit. I like limits because they take very little work. Once you kind of learn what to look for, look from the left, look from the right. Usually they're about 4-second questions, very quick. But again, if this is your first time seeing these, then there is a little bit of a hurdle. You just have to do enough of these until it kind of clicks and you just focus in on what you're looking for. Okay, I know a lot of you have checked some of these, but for the first question, I will go ahead and put up my answers. That way, if you did not get the answer key from me for a moment to check those, if there's any of those you want to hear the explanation to, or any of those you think I got wrong, because I do miss these sometimes, I'd be happy to go over those with you. So, check this number 1. And I guess I'll go ahead and put up number 2 also. Okay, is there any parts of this question 1, any of those 9 parts you want me to go over with you? Even if you got the answer right, if you just felt like it was harder and you were unsure. Okay, check the second group and I will offer for that also. Okay, any of these 9 parts of number 2 that would be helpful for me to go over? Okay, somebody just pick one to make me feel better. Something from number 2.
B.
B, okay. Okay, so f of 1, notice it doesn't say limit on it, so this is not a limit question. This is just a way to ask for a point. When x is 1, what is y? And so when I go to x is 1, x is equal to 1, it never hits the graph at x equals 1, the open circle. Okay, any others from the second little section? Okay, let me give you just 1 minute here to kind of finish your thought on this. I will give you some more class time in a few minutes to come back to this. This is the one assignment I want you to finish up between now and Thursday. So finish your thought. I don't think anybody's finished with it. That's okay. We're just going to look at the next handout. We're going to start it and start to think about it. And then I'll give you the rest of the class to actually finish number 3. Number 4, assignment handout number 4 is not going to be homework. We'll spend more time on it together on Thursday. Number 3 is the only one I want you to finish up completely between now and then. So again, these topics, a lot of this doesn't necessarily carry over for everything we do all year, but these will show up on your AP exam. So honestly, just from this practice, there is a question or two already that you will see at the end of the year on your AP exam. These will be on your AP exam. Now there's not going to be 10 of each of these because they only need 1 to see if you know what you're doing, but already you've got something under your belt. Okay, again, just put that aside for just a second. Okay, maybe not. Here we go. Okay, I don't think I numbered this one. Is that correct? Is there a number on this? Okay, so this needs to be number 4. Again, please just put the 4 on there if I didn't put it on there for you. That's also, not only is the numbering important as far as like having a resource before your AP exam for you to go and find things, it's often how I ask you to turn in assignments. So like when I see you guys on Thursday, I'm going to say, I'm about to take up assignment 3, we're going to do this, this, and this with it, and then I'm going to take it up. You need to know what assignment 3 is. Next week when I ask for assignment 4, you need to know what assignment 4 is. If you turn in something else that's not assignment 4, then you might get late credit or something because you didn't know what to turn in. So again, it's next to no effort. Put a 4 on there, put it behind number 3. Okay, so this one, we're not going to practice this one much today. I just want to give you the heads up and get your brain to be thinking about this and comparing it to the first handout. So we now know generally what a limit is asking. It's asking you what y value is the graph approaching as x gets closer to this. But there's 2 question types. Sometimes you have a graph like assignment 3. All of these have a bunch of graphs for you to look at, and that's perfectly good questions sometimes. But then sometimes we need to do it algebraically or analytically, same thing. Where instead of this just being a generic f of x, it actually tells me what f of x is. Now, if I knew what this graph looked like, I could do it like the last handout. I could just look at the graph, see what y values it approaching to the left of -1, what y values it approaching from the right of -1. If they're the same thing, that's my answer. But graphing that's going to take way too much time. Even if I have a calculator, it takes too much time. So we are going to do this process called direct substitution. You always do this first. Always try direct substitution first. All direct substitution means is you're going to take the value it's approaching and plug it in everywhere there's an x. So if I plug -1 in for x, it looks like this. Do the arithmetic, and if you get a real number, like -5 is a real number, you can assume that's your answer. Now, again, I don't know anything about what this graph looks like without spending a lot of time, but what I just did in about 10 seconds of work is I figured out that this graph gets closer to a y value of -5 the closer x gets to -1. So that doesn't guarantee that there's a point there. I guess there actually is a point on this one, but it tells me that it gets close to -5 as x gets close to -1 from the left and the right. Still tells me something about the graph. Okay, doing number 2 with direct substitution. This one throws students off sometimes, so I like that they put this one in here early. You try to direct substitute 2 in for x. but there's no x's to plug it into. So you plug it in everywhere you can. You're left with just this. 2 had nowhere to go, so there's your answer. It's even easier. And to try to make a quick little connection for you about why that works the way it does, imagine that this is a function. What is the graph y equals, or f of x equals 6? What does that look like? A what line?
Straight.
Well, all lines are straight. Horizontal line that goes through y equals 6, right? So does it even matter what x value I'm approaching? Do you see no matter what x value, it's always approaching a y value of 6? So that's basically the same thing. When you try to do direct substitution, it doesn't matter what you're plugging in because there's nowhere to plug it into. So, okay, and then we start to branch out, and we're still doing direct substitution first. If I plug 0 into this, the numerator goes to 0, the denominator goes to 0. If I plug in -7 into this, well, it's kind of hard. The numerator's a little tough, but it goes to 0 and the denominator goes to 0. Calculus handles a lot of different math problems that you just can't deal with from other math classes. This is the first one. This is called indeterminate form. So what you need to remember from previous math courses, if you take a number like 0 and divide it by some other number, you get 0. 0 divided by 3 is 0, 0 divided by 7 is 0. If you take a number other than 0 and try to divide it by 0, we can't divide by 0, so we say this is undefined or does not exist. You've heard those two for years. But in calculus, one of the first problems we deal with is 0 over 0. It's called indeterminate form. And 0 over 0 can be anything. It could be 0, it could be undefined, it could be 7, it could be 5.2, it could be 2.1. It depends on how fast the numerator is going to the number based on the next value and how fast the denominator is going to that number. So when direct substitution gives you 0 over 0 and we don't know what that comes out to be, we have to figure out a process to deal with this. So the only one I want you to think about today is factoring, and this is the most common way to deal with this. I can promise you your first quiz in a couple of weeks will have at least one of these, because I can promise you your AP exam will have at least one of these. But our process is going to be, let's make this look different with factoring. So that could be GCF. I'm just going to do them both at the same time. That could be factoring a trinomial. If factoring is a weakness of yours, then you need to practice that and get yourself up to speed. We don't factor every day in here, but factoring is important to survive in calculus. Now that I've factored, something should cancel. Times x divided by x cancels. X plus 7 divided by x plus 7 cancels. And as soon as something divides or cancels, now you go and try direct substitution for the second time, plug it into what's left over, and if you end up with a real number, that's your answer. Plug it into what's left over, and if you're left with a real number, that is your answer. So this isn't the only way to deal with 0 over 0. It's the most common way to deal with 0 over 0. The only one I want you to be worried about and thinking about today. You get 0 over 0, factor the numerator, factor the denominator, cancel something out, and then finish with direct substitution. So once again, this is a little bit of work, and maybe you could care less about this question. Obviously, it's just some generic question, but I have no idea what this graph looks like. But from this 10 seconds of work, I can tell you the closer x gets to 0, the closer the y value gets to -5. If you graph this in your calculator, the closer x gets to -7, the closer y gets to -15. I know something about those functions with very little effort, without a calculator, without the graphs, without spending all day on them, etc. So that's one thing that limits do. Okay, so let's look at question 5. We're only going to do just a touch more on this one, and then we can put it away till Thursday. You can go back to the other one and finish it up. Okay, so I do question 5, and if I had asked you to do this, to see if you fall into this trap, we're just going to do it together. You're going to think, all right, he told me to factor, cancel, and then do direct substitution. But I factored and nothing cancels. So what did I do wrong?
This is direct substitution first.
Very good. Always, this is why I wanted you to write it this way, always start with direct substitution. Just because it factors doesn't mean it's going to be one of those you have to factor. Now, if it helps you to factor it, you can. It's just that it's not, this is not 0 over 0. This is 15 over 0. And what is 15 over 0 going to go to? Right, does not exist. Only 0 over 0 is the complicated questions. Always start with direct substitution. Hope that you're done. If you're not done, consider factoring and canceling. So if you fall into that trap and say, oh, I know I got to factor, just let me factor, you're going to do more work and it's going to push you into the wrong answer sometimes. Okay, the last thing I want to say about this handout today is there's some of this you're not going to be on the hook for early this year. So these are special limits. You can put an X through those. So years ago, we used to make students memorize these. I think a lot of calculus teachers still ask students to memorize these at the beginning of the year. But it's kind of silly because once you know how to do derivatives, and about 4 weeks from now, I can show you something called L'Hopital's rule where you can figure out what these limits are without memorizing them. So I don't like you to memorize them because I don't think that sticks long term. And again, with L'Hopital's rule, once you know derivatives, you can figure them out in about 30 seconds, 20 seconds. So I have no interest in you memorizing those just for the first week of school. And 6 through 8 are those question types, so I'm not going to hold you to those. Again, in about a month, you should be able to come back and do those. And then on the next page, you can see we've got some practice questions. So one of the things we'll do on Thursday is I'm going to spend 2 minutes reminding you about that front page. Direct substitution, you get an answer, circle it. Direct substitution, you get 0 over 0. Try to factor it, try to get something to cancel, and then do direct substitution. You don't have to practice any of these today, though. You're not on the hook for any of this. That's all I wanted to do on that assignment. I would like you to spend the rest of your class time on number 3. So that's the one I would like you to try all of between now and Thursday. And you've got 22 minutes of class. So if you can finish that up in 22 minutes, that's great. You've got no homework. And if you don't finish it up, that's not a problem. Just make sure you do it before class on Thursday. All pass? Yeah, it's over there.
You have more than one or just I just have the one.
They give us 2, but the second one's supposed to be for emergencies, like if the office calls for somebody, I've got to give them a pass.
Yeah, that's no problem.
I have, right now. I have, oh yeah, I have work today. Wait, no. Maybe it's 6. I have the letters and then script.
Should be 5. Only increasing from here, drop that point down a little bit so that this can be increasing. Okay, that's fine. It's increasing from -5 to -3. definitely increasing there, and this has got to be decreasing.
I have a bachelor's.
Yeah. That's all you
Yeah.
You didn't.
Yeah, the first one.
Yours looks almost exactly like mine. You put a point there, but you don't have to put a point there, because it didn't say you had to. That makes sense. Have you checked some of your work yet? In the other place?
I think it'll be a fun school year. Yeah. Something will be good.
That's correct. So if you want this one to be bigger, you want it to be bigger from the left. Just don't let it connect straight there, just make it go higher up. That way the limit from the left is 6, and the limit from the right's almost 5. And then that's,
This was the error.
that's fine. Check this.
This one, I think I'm moving something, but.
Number 3? The problem with number 3 is, I don't think most of you guys know what the greatest integer function is. It's a parent function, so back in the day, students had to memorize it. I think that question's just really old. The good news is, they don't expect you to know it for the AP exam, so you don't have to study it. Greatest integer function. Did they write it like that, or what notation did they use? The brackets? Have you ever heard of the step function?
I don't know.
Okay. The greatest integer function is like rounding, but you always round down.
Okay.
So if your number is somewhere between 0 and 1, you just round down to 0.
Okay.
If your number is somewhere between 1 and 2, you round down to 1. If your number is somewhere between -1 and 0, you round down to -1. So it's sometimes called the step function because it kind of looks like steps. So for your question, you need to know that to know part of what that fraction is. But again, don't stress about memorizing that. You don't need to know that. Now, my plan is to scan this in this afternoon and add it to the website. So especially if this is a hard topic for you, or this is the first time you're hearing it, you should always go and check your answers, to be honest. If you're doing something wrong and you don't even know you're doing it wrong, that's a bigger problem than at least knowing that you're doing it wrong. So, I know some of you won't finish this in class, and that's okay, but just make sure that that website that you bookmarked for me, that you scroll down, check your answers, and if you make a couple mistakes and you see what your mistakes were, it's not a big deal. I wouldn't worry about it. But if you miss 10 questions, start trying to iron it out and figure out why you missed it. Don't just keep kicking the can down the road. Calculus definitely builds on itself, so some of the stuff we do will make it harder for you if you don't get a good grasp on what's current. 2.5. Yep. That's correct, so there's an asymptote. Or an asymptote, you know, like that shoots up and shoots down, it could be either one of those. And since they don't say in here, you can do whichever. So, point, undefined, also limit. Two from the left, plus two from the right, which is constant. And decreasing everywhere else. Is that decreasing? Oh, no. Yeah, we need to make it. Yeah. Okay, that was fine. 2.5. And right here, though, this is supposed to be a function. You see this? This doesn't pass the vertical line, so you can't do that. I'm talking about this little tail with that little tail. Yeah, you got one or the other, not both. You related to Aaron? Yeah. How's she doing? I had her in class a couple years ago. Yeah. She was good at calculus. I don't think she liked calculus, but she was pretty good at it. Which one was hard? Did you see what I said about this function? They're point at negative 2.5. If we approach 1 as x gets closer to 2. Oh, negative 2, my bad. Yes. Only from the right. It's got to be from the left also. So it doesn't say just from the right, so it's got to be both. Oh, so then just consider that. Just from the right of 4 should be 3. X is increasing, and x is less than, this says x is less than -2. Okay, it always points at the smaller, or alligator. So yeah, you need to switch those directions. This pen's not working out so well. No, it was working well out of it. And 4 from the left to be less than 4 from the right. It doesn't matter as long as it's from the right is bigger than the left. It doesn't matter what else. Good. I don't know. Sometimes yes, sometimes no. Point. Okay, so first is 1, you need to have -2. But you only have it from the right, you need it from the left also. So you got I need to get one of those right things. I'm sure you're pretty out you told you that last time. Or just do a pencil. Okay, 3 from the right is supposed to be. Oh, my bad.
It's just saying that.
Okay, from the right is 5. So you know that.
One of them is greater than the other, and just choose one.
That would be
Only increasing here enough time, so this must be decreasing.
Yes, you put some information down, and then
wait.
there's like another one.
I'm gonna go on.
Probably on negative. The negative is one directly beside it.
-3 from the left. What is it?
No, neither of the clocks work.
You said 6 here, but you connected it with 5. I think if you made it go up a little higher on the left side. But you also need to finish the rest of this graph. Really? Yeah, it doesn't just magically stop there. I disagree with 3 and 4. 3 is kind of understandable because most people don't know what the grades are. I like that. It's fine if you, you don't have to know that. This one, F of 1 is 3. The limit of x approaches 1 is 1. Those aren't equal. That's not a true statement. Yeah, I got this. Yeah, so again, that's the greatest integer function. Most of y'all just have to see that before. I sketched it real quick, but we'll talk about it for a second. Okay, I want to be super clear here, just to make sure you guys know what you need to do. This handout number 3, I would like you to try all of this. Whatever you didn't get to in class, try the rest of it. Check the website later. You might have to refresh it, but I will have the solutions on there. Check your work. If you're missing a ton of it, put some time and some thought into it. If you're doing great, that's wonderful. But we need to kind of have that checked out. Make sure you bring your binder and number 4 with you on Thursday because we're going to work with it some more.